This problem is also going to require a numerical answer because we've got the limits of integration there. We have 0 and 2. First thing you want to look for is the u. The u is usually what you have inside of something else. So in this case, we'll let theta cubed plus 1, we'll have that as our u. U equals theta cubed plus 1. You're just going to take the derivative of both sides. So you get du is equal to 3 theta squared d theta. Derivative of 1 is 0. And then you want to solve for d theta. D theta is equal to du over 3 theta squared. Now we want to put this into the original one. So we have theta squared is still there. And then we have square root of u. And then d theta would be du over 3 theta squared, like that. Now what's going to happen here is there's a 1 that's still there. And so the theta squares are going to cancel out. And then you have a 1/3 that's going to go on the outside of your integral. So 1/3 goes there. Now I have a u to the square root of u, so I'm going to make that u to the 1/2 power right there. Now I'm going to use the inverse power rule in order to do that, reverse power rule. So 1/3, I have u raised the power by 1, 3/2, and I'm going to divide by 3/2. So just using the reverse power rule there. We're going to flip and multiply that. So 1/3 and then times 2/3, u to the 3/2, and that's going to equal 2/9. And instead of the u, I'm going to put in the original definition for u that we have there, which is going to be theta cubed plus 1, and that's still going to be raised to the 3/2. And that's going to be from 0 to 2. So this is the main formula that we're going to use now to evaluate that. We'll put the 2 in there first, and then we'll put the 0 in that. So I'm going to write that up here on top so we have more space. Okay, so first I put the 2 in there. Okay, so I have 2 that goes in the first formula. Now I'll put 0 into there. Remember that even though you put a 0 in, doesn't automatically mean the whole thing's going to turn into a 0. You have to still evaluate that and be careful with these kind of problems. So for this, it's 2/9, 0 cubed plus 1 to the 3/2. So now we just have to evaluate each of these individually. Now the first one that we have here, this is a 2/9, might be hard to see on the board. That's 2/9 there. This is a 9 inside, so we get 2/9 times 9 to the 3/2 minus 2/9 times 1 to the 3/2. Now you can put this into your calculator to find that. If you do 9 to the 3/2, you're going to get 27. So I have 2/9 times 27. And then I have the other one's just going to be 2/9 because 1 of the 3/2 is 1. So I'll put 1 there, but that's what you have. So now you just want to put that into your calculator. So for each of those, once you put all that in there, let's give you the final answer here will be 52/9 when you get common denominators, or again, you can just use your calculator for that one. But this right here would be your final answer.